Hey folks, today's topic is the chain rule. This adds to our toolbox or toolkit of things, tricks that we can use to help us derive functions. So we have the derivative shortcut, which is old news. And then last time we talked about the product and quotient rules. So I'm going to give you a pop quiz here. What is the derivative of u times v? And another pop quiz question, what is the derivative of u divided by v? I'll give you a second there. Pause it, fill it out. You should know these by memory. All right, if you haven't memorized these yet, you need to memorize these. These are big, big things. You're going to see these for the rest of the class. So the derivative of the product rule is u prime v plus u v prime. Those are multiplies in between. I'm not going to put them in there, but those are connected by multiply. And then the quotient rule starts off the same as the product rule, except there's a subtract in the middle. So it's u prime v subtract u v prime over, and then you got to remember to divide by v squared. So today we're looking at this thing called the chain rule. And the idea of chain rule is that you've got these layers. You've got these layers and the derivatives get derived by the layer. So, I mean, he's sort of explaining if you've got some function, and I'm not even going to try to explain that. It's not worth it. So here's what we're looking at. What I want to talk about is this idea of layering. Okay, so this is not there is something inside of another function. This x is inside of a squared, but what's the derivative of x? 1. So we don't think about that as being a function with layers. This is just what I can just go ahead and derive this thing. I can derive this 2, bring it down in front, minus 1. This is just the difference rule. I look at this. What's the derivative of sine? Hopefully you remember that it is cosine. Here we go again. This is the difference rule. Here we go again. This is the difference rule with some trig rules in there. The idea of the chain rule is that you've got a function inside of another function. So if I were to highlight this, if I look at this, here's my x squared minus 1 again, but where is it now? It's inside of a square root. So I've got this layering. I've got this idea of something inside of something else. Same thing here. Now remember, when we say sine of, just like you see this square root that goes around x squared minus 1, you have to think about sine as being that same thing. Sine is something that goes around a function. That's why we say square root of x squared minus 1. That's why we say sine of 5x. This 5x, even though they don't put parentheses there, that 5x is considered inside of this thing called sine. This one's really obvious. 3x, the function 3x subtract 2 is inside of the function to the 7th. And then this is x minus tangent of. So the inside piece might actually just be a small portion of the function. It's not the whole thing. Like, kind of feels like the inside is the function is inside, all inside something else. It can only be a certain portion of the function. So the idea of this, what we're going to say is we're going to say something. We're going to say this like, how do I want to put this? Let's take this one. I'm going to ask you, what's the outside function? Sine of, and we're going to use the phrase something. And then what's the something equal to? That's the 5x. But the idea is, I don't want to say that my outside function is sine of 5x. That's not true. The outside function is the sine function. So we say sine of something. Like here, what's the outside function? It's square root of something. And we're going to talk about how to derive that. What's the outside function? Something to the 7th. Those are the functions. So let's do an example. I think that's probably the best way to explain this. But before we do that, actually, you know what? Let's do it right here. I think there's more room in this box. I'm going to give you another pop quiz before we talk about the actual how to do the chain rule. I want you to tell me what are the 6 trig derivatives. What is the derivative of sine? What is the derivative of tangent? What is the derivative of secant? And this is a hint the way that I'm writing it up. I'm writing it up in a way that should give you a hint. There's something in common about all of these. And then what's the derivative of cosine? What's the derivative of cotangent? And what's the derivative of cosecant? All right, hit pause. See how many you can get done by memory. All right, let's see how you did. The derivative of sine is cosine. The derivative of tangent, I actually wish I would have written it the other way. I like to think about the secant one first. I remember secant starts with secant, and then it changes to tangent. Tangent starts with secant, but it stays as secant. So it's secant with another secant, which is secant squared. These are the 3 that I have memorized. Then the other 3, I just remember a couple of tricks. The first trick I remember is they all start with cosine, cotangent, cosecant, which means their derivatives all have a negative out in front. Now the derivative of sine is cosine. Derivative of cosine then would be negative sine. If the derivative of tangent is secant squared, the derivative of cotangent is cosecant squared. If secant starts secant and goes to tangent, cosecant starts cosecant and goes to cotangent. If you do not have these memorized, you must memorize these. Memorize. Memorize. If you don't have them memorized yet, do it. Do it. Do it. Okay. So, the derivative of what we call functions that are composed. So these are composed functions. That's where one function is inside of another function. You might remember this from pre-calc. Well, actually, we've done it a lot in our high school curriculum. You might remember it from Algebra 1. You might remember it from Algebra 2, I hope, but you definitely should remember it from pre-calc and then even earlier this semester when we had one function inside of another function. So I've got my outside function. What I do is I take the derivative of that function and I leave the inside function the same. Then I take my inside function and I multiply by the derivative of that function. So what's a good way to write this up? Let me think here. Derive outside, leave inside. So I derive the outside piece of the function, but I leave the inside function the same. Then I multiply by derivative of the inside function. So this ability to recognize outside functions and inside functions is key. And there's really not a great way for me to teach it to you, unfortunately. But if you do a rewrite, usually it's pretty obvious. Usually it's not too bad. So let's go back now. If you notice, these were the first 4 examples on the other side. These are the ones that we were talking about with the chain rule here that he left as an example. So now let's actually do the chain rule. So what I want to do is I want to rewrite this in a way that helps me understand who is the inside function and who is the outside function. So I'm taking the derivative, d dx, of x squared minus 1. Now you want to do a rewrite here, just like you want to do a rewrite if you had the square root of x. You would rewrite that as x to the, you guys got to memorize this, 1/2. Okay, so what you want to do here is you want to think about this as something. What's the square root of something? That's the same as something to the 1/2. And that's how we want to think about this. So my something is the x squared minus 1. That's inside of the square root. So when I rewrite this, I'm going to rewrite this as my something to the 1/2. Okay, so who's our outside function? To the 1/2. So what's the derivative of something to the 1/2? Derivative of something to the 1/2 would be 1/2 something to the negative 1/2. So that's what we're going to do down here. I'm going to derive this x squared minus 1 to the 1/2. What's the derivative of something to the 1/2? It's 1/2 something, but what's our something? X squared minus 1, and then I subtract 1 from the exponent, 1/2. Times by, okay, now I still need to derive the something. So in other words, we've kind of like taken care of this layer. So you can kind of in your head, you can either literally cross it off, or in your head, just picture it crossed off. And now I need to derive the x squared minus 1. Well, that's just a difference rule, and the derivative of x squared is 2x. The derivative of 1 is 0, so I don't need any parentheses, but I'm going to put them anyway, just to help us remember that you need to times by this whole quantity, whatever that derivative is. And then let's try to clean this up. So a couple things I noticed, my 2's are going to cancel. 1/2 times 1 is 1, so we don't need to worry about that. This has a negative exponent, which is going to put it back on the bottom. 1/2 as an exponent becomes a root again. This x would not be on the bottom. That's going to be on the top. So this ends up being the x stays on the top. This is going to flip to the bottom, and it's going to turn back into a root. That's a lot of cleaning up in my head, but if you stop and think about it, you'll, I think, see the same thing. Okay, let's try the other one. Next one. Try to do a rewrite first. d dx of, and I want to rewrite this in a way that there's a something on the outside and a something on the inside. Okay, so again, you might not think of it this way, but you need to start thinking about it this way. How is sine connected to 5x? It's not by multiply. It's sine of 5x, sine of 5x. So that 5x is inside of this thing called sine. So we would rewrite this as sine of 5x. Okay, now who's my outside function? Sine. So what's the derivative of, we don't want to just say sine, sorry, that's a bad habit to get into. We want to say sine of something. So my outside function is sine of something. Well, what's the derivative of sine of something? Cosine of something. So for us, this becomes cosine of, what's our something? 5x. So notice I derived the outside layer into cosine, but I left the inside layer the same. Multiplied by the derivative of the inside. So what's the derivative of 5x? Is 5. And usually with your trig stuff, you want to push all constants out front. So we would have 5 cosine of 5x. Now, you don't need the parentheses at the end there, but I like to have them because it reminds me that 5x is actually inside of this weird thing that we call cosine. I think you're up. I think you're up. Let's go. You can do the next one. Do you need to do a rewrite? I would say no. You already can tell. You can look and tell who is the inside function and who is the outside function. All right. Give it a try. All right, let's see how you did. So my outside function is something to the 7th. So the derivative of something to the 7th is 7 something to the 6th. The derivative of something of x to the 7th becomes 7x to the 6th. Well, if I take out this x and I replace it with 3x minus 2, I'm going to replace that with 3x minus 2. So I would get 7 times the quantity, 3x minus 2, and that still needs to get raised to the 6th power. But that's not the end, because we still need to derive the something. What's the derivative of something to the 7th? 7 something to the 6th. What's the derivative of the something? Derivative of 3x minus 2 is just 3. We like to push anything that's free together. So like the 7 and the 3 can be multiplied together to make 21. 3x subtract 2 to the 6th. I would not want to expand that. I could using Pascal's triangle, but I definitely would need a lot more room than we have in that little space. All right, part D, do a simple rewrite. Instead of a, don't do a rewrite over here. Just add something to this to show who is the something, who's the inside, who's the outside function. All right, let's see how you did. X is just X minus tangent of, boom. That word of means that you've got something inside and outside. So tangent of x squared. All right, so what kind of rule is this? So these were nice.
Here's some information.
Sorry, Siri. I don't want any help there. Overall, what type of problem is this? What rule would you apply overall? Like these were just one-step derivatives. There was not really anything complicated about them. This is a little trickier. Okay, overall, what type of problem is this? What type of rule is this? This is a difference rule. So that's good because you can derive each piece. So the derivative of x won't be a problem. The derivative of tangent of x squared. Okay, whoa, that's a chain rule. I've got something inside of something else. So this is a difference rule with a chain rule. So as I derive, I can just start deriving each piece because it's different. So the derivative of x is 1 minus the derivative of tangent. Okay, so my outside function is tangent something. What's the derivative of tangent something? You should have this memorized. If you haven't yet, you need to. Derivative of tangent is secant squared. So the derivative of tangent something is secant squared something. So down here, our something is x squared. So this would become secant squared of our something times. And right away, I write that times. Anytime I say the word something in my function, or in my derivative, that means I still have to go another layer. So then I need to now derive my something. I've derived the tangent. In a sense, you could cross this out or just not think about it. And we still need to derive x squared. The derivative of x squared is 2x. And generally, we like to push anything that's not trig to the front of that trig term. So I would have 1 minus 2x secant squared of x squared as my function. Okay, now I think the rest of these are kind of pointing out the power of the rewrite game, the ability to rewrite and save yourself some headaches. This can be rewritten as the derivative, d dx of. Okay, now this is a group. This is x plus 1. The problem is that x plus 1 is on the bottom, which means I can't do my derivative shortcut. So stuff on the bottom, you can take all of it and put it on the top as long as you do what to its exponent? Well, hopefully you said switch the sign. So if I want this x plus 1 to be on the top now, I'm going to make it x plus 1 to the negative 1. Now I've got this thing that I can do the chain rule on because this is my something. Something to the negative 1 is something that we can do by the power rule. So the derivative of something to the negative 1 is negative 1 something. Subtract 1 would be negative 2. Notice I put the times in there right away because when I did this, I said the word something. That means we need to still derive. So as I derive the x plus 1 now, the something, I just get a 1. Okay, let's clean this back up. This is pretty easy to clean up. Let's think about what stuff would end up being on the top. I'm going to have a negative 1 times 1, which would be negative 1. And then this piece is going to flip back to the bottom over x plus 1 squared. I like the next one. This one's interesting because this has 3 layers to it. See if you can rewrite this and figure out where all the layers are. Just try to put some parentheses in there. All right, let's see how you did. Okay, so let's review. What does sine squared really mean? Sine squared really means that there's a squared around the whole thing. So I like to actually, when I'm doing the derivative and I see that I'm going to have a chain rule, I like to cross this off and put parentheses around the whole thing and put the squared where it actually belongs. Mathematicians are a lazy bunch of folks, and so they don't want to write parentheses if they don't have to. That's why they came up with this system of putting the 2 right on the sign. Well, when you try to do the chain rule, that gets confusing. So whenever I see a sine or a cosine or whatever to a power, I cross it out and put it around the whole thing. Okay, so I said that there were 3 layers, but it looks to me like there's something to the second, right? Well, don't forget, what is sine? How would you say this? This is sine of, boom, right there. That means that you have another layer. So this is the same as the quantity of sine of 3x and then the squared. So my 3 layers are, my outermost layer is something to the second. Then my next layer is sine of something. And then my next layer is 3x. So we just derived the chain rule that you can have as many layers as you want. You just start off with the outermost layer. So for us, the outermost layer is something to the second. So what's the derivative of something to the second? Would be 2 something, and we write the something exactly as it was before. So I left that exactly the same. And then we subtract 1 from our exponent. So the derivative of something squared is 2 something to the first. I said something, which means I have to keep going. Okay, so now we've taken care of the 2. If you want, cross that out. And you just have sine of 3x. What's the derivative of sine of 3x? Well, that's sine of something. So the derivative of sine of something is cosine of something. And our something was 3x. I said something, so I have to keep deriving. Now, you could cross out the sign. You've already crossed out the squared. You could cross out the sign, and you're left with just 3x. What's the derivative of 3x? 3. Notice I didn't say something, so I don't have to keep going. All right, so now we would try to just kind of clean this up. I would take all my coefficients and push them out front. 2 times 3 is 6. And yeah, there's nothing we can do really with these, so I'm just going to rewrite them. All right, you're on the spot here. Let's give you a chance to try this on your own. Hit pause and try to get as far as you can through G. All right, let's see how you did. What color here? I'll go with a nice purple. Well, we just kind of went from a dark color. We like to mix it up. Let's go with a nice reddish thing, whatever color this is. All right, so overall, what type of rule? I'm looking at this. I've got x times, all right, right there. That's a product rule. This is a product. Okay, so there's x times something. So when I derive x, that's going to be easy. When I derive secant of something, oh, that's a chain. So this is a product rule with the chain rule. So if I'm going to do a product rule, that means I have to have u's and v's. U equals x. U prime equals 1. V equals, oh boy, secant of x squared plus x plus 1. So V prime equals, all right. So this is going to be one of those scenarios where you're going to want to write as small as you can because this is going to get pretty long pretty fast. This, when I derive this, this is a chain rule situation. So secant of something. Without looking to the top of the paper, what's the derivative of secant of something? Hopefully you said the derivative of secant of something is secant something tangent something. So secant of x is secant x tangent x. So if I change this x to something different, then both of these x's have to get changed to that same something different. So for us, secant something would be secant something tangent something times, because I said something, times by the derivative of our something. Our something is x squared plus x plus 1. Now, this is a quantity, and this is why you want to get in the habit of writing as many parentheses as you can. 2x plus 1, because that thing is grouped. I'm actually going to go up above and try to add that to these to remind myself that I always want to multiply by something in parentheses. Oh, geez, I got to do it to every one. Annoying. Now, on these, if you forgot the parentheses, that's all fine and good, because those are all multiplying by single terms. Even this is a single term. It's 2x. Down here, if you forget the parentheses, you lose a point out of 2. You lose half the points because of stupid parentheses. But yes, you must speak properly. We must say what we mean. Okay, so now we've done the U's and V's on this. Now we need to actually go back and apply the product rule. So what would be a good color with this? Maybe a blue. All right. So it's U prime V. Product, thank goodness, it's a plus. UV prime. So I'm going to try to squeeze as much as I can into this little space here. U prime V, well, that's nice. 1 times secant of this is just secant of that. So secant of x squared plus x plus 1 plus, and let's see if we can save ourselves a little bit of a cleanup here. I'm going to do x times this, but this thing is really going to be pushed out in front. So we like to push everything that's a not trig into the front. So I'm going to have an x in front. I'm going to have this in front. So let's just distribute this directly into this. So that's still a quantity. X times 2x is 2x squared. X times 1 is x. And then we're multiplying by, now here I don't need parentheses because these are already connected by times, and the stuff inside of them has their parentheses. So we're good there. So this would be secant squared of x squared plus x plus 1, then tangent, not secant squared, my bad, sorry. I had squareds on the brain because of this. It's secant tangent of x squared plus x plus 1. I would argue that this is probably decently cleaned up. You wouldn't have to clean this up a whole heck of a lot more, but maybe you notice that both of these have a secant of x squared plus x plus 1. So maybe we could factor that out. If you don't do this move, I wouldn't think it's a big deal. But I'm just showing you how you might see a multiple choice answer. So if I divide this by secant of the same thing, don't forget it's not nothing. It leaves behind a 1. Plus, I'm taking this out front, which still leaves these two pieces. So that would be 2x squared plus x, tangent of x squared plus x plus 1. Whew! That's a doozy. That is a doozy, all right. All right, let's have you try the next one again. So pause, see how far you can get. So I'm not going to have enough room. I'm going to try to write it down here. So my rewrite. So first of all, what type of rule is this? Let's see if we can identify our rule first. What would be a good color that would show up in comparison to these? How about some pink? No, red. Pink. I think I'm going to go green here. Green would be a good distinguisher. All right. Overall, what type of rule is this? Secant of something. So overall, this is a chain. With, as I go look at the thing that's the something, derivative of 4 is nice. That's a difference. So the inside of this is a difference. But as I derive the difference, the derivative of 4 is gone. That's no problem. But trying to derive this, I'm going to have to do the chain again. You don't have to do this, but I think it's helpful to make sure that you understand what the rules are that you're going to have to apply in this situation. All right, so let's go ahead and try to see if we can derive this thing. So who's our outside function? First layer is secant of something. What's the derivative of secant of something? Unfortunately, it's the one that has two. It's secant something, tangent something. So it's almost too dark now, isn't it? Let's go to maybe 70. All right, secant of something is secant something tangent of something times, because I said something, we have another layer to go. Now we're doing the derivative of this. This is a difference rule, so I derive each piece. What's the derivative of 4? It's gone. What's the derivative of this? Oh, I got to do some work here. I'm going to do some rewriting. So I'm going to add 2 parentheses to this scenario. The first one I'm going to add is I'm going to take this out, this cubed out, and I'm going to put it around the whole thing. So my outermost layer is something cubed. Then I have another layer because it's cosine of. Every time I say of, I have to put a parenthesis. So this is the cubed of cosine of 5m. So 5m is going to have another layer around it. So this is one of those functions that has 3 layers. All right, so here we are. We're back at we've done the outside layer, secant of something. It's secant something, tangent something. Now I'm deriving the difference rule. Derivative of 4 is gone. Life is good. Now I'm trying to derive something to the third. So that would be 3 something to the second with that negative. So don't lose the negative. So that'd be negative 3 something to the second. Okay, so now we've taken care of the cubed, but I said something, which means we still need to keep going. Okay, our next layer is cosine of 5m. Cosine of means something. Cosine of something is negative sine something. So negative sine, and our something is 5m. Times, I said something, which means we have to go another layer. Our something is 5m. The derivative of 5m is 5. We are not going to try to clean that up. Number 1, I don't have room. Number 2, I guess what would I do to clean this up? I would take this 5, this negative 1, this negative 3, and I would push a 15 out front. And then I would only put this squared back on that cosine and just call it good anyway. There's nothing we could do to make that look any nicer. Okay, last one. So first of all, decide what type of rule this is. This one I think we'll do together. All right, so overall, I've got something raised to the power of 2. So that means I said something. So that means we're going to start off by doing a chain rule. Where's purple? Maybe I'll do a nice purple in here. Maybe will that show up? No, I'm going to go back. I'm going to use this red. All right, so overall, I've got something to the second. So that's a chain. With, as I derive the inside layer, I've got a division, which is a quotient. And then when I derive each one of the pieces of the quotient, those are just polynomials. Those are different sum rules. I don't usually write those up. If you wanted to write another with, you could there. I'm not going to bother. All right, so chain rule. So that means I start off by deriving the outside layer, something to the second. The derivative of something to the second is 2 something I said something, that means I've got to keep going, times the derivative now of my something. Well, the derivative of this is a quotient rule. So I'm going to now do quotient rule. Maybe I'll use purple for that. That's too close to this red. Let's go with I need more colors. How about this? Nah. All right, this dark blue. Okay, so now I'm going to do a quotient rule. U equals 3x minus 1. U prime equals 3. V equals x squared plus 3. V prime equals 2x. So there's my product rule. Product rule is u prime v minus uv prime all over v squared. So 3 times, I'm going to distribute to save us some time here. I'm going to distribute this and go. You know what? Never mind. I don't have enough room. We're just going to have to live with it as it is. So that's going to be, now I like to use a bracket here. You could also use a parenthesis. So it's 3 times this, u prime times v. 3 times x squared plus 3 minus uv prime. Now look, uv prime is those multiplied together. I'm going to put that one first because that one doesn't need parentheses, and the next one does. 3x minus 1 all over v squared. I guess we got a little bit of room. Let's clean this up a little bit. Oops, I forgot my squared. So let's see, if I clean this up a little bit, maybe I give this 2 to the first one. So that's 6x subtract 2 over x squared plus 3 times, distribute is 3x squared plus 9 minus 6x squared plus 2x all over x squared plus 3 squared. And we could do a lot more cleanup here. Like we could try to combine like terms here and then distribute and then multiply because we have a common denominator. I mean, we don't need a common denominator, but we would just make this into x squared plus 3 cubed and go that route. But we don't have to. We could do that. If we had more room, we'd do it, but we don't have more room. So that's what we're stuck with. What do you think? Okay, so let's stop there for now, and then I'll make another video to finish up our notes.